NENOMATICA, where mathematics meets YouTube excellence. Welcome to our introduction to inequalities in mathematics. In this video, we'll explore the fundamental concepts of inequalities and their various forms. Let's begin by looking at our chapter outline. We'll start with an introduction to inequalities and real intervals, followed by their key properties. We'll then cover basic inequalities, maxima and minima theorems, and various mean inequalities, including the arithmetic geometric mean inequality, harmonic geometric mean inequality, quadratic arithmetic mean inequality, and harmonic arithmetic mean inequality. Finally, we'll explore Bernoulli, Young, Hilbert, and Huygens inequalities. Welcome to this math video where we'll be learning about comparison methods for real numbers. We'll explore two different ways to compare real numbers, understand when to use each method, and see some practical examples. When comparing two real numbers, let's call them A and B, we have two main methods at our disposal. The first method involves subtraction. We calculate a minus B to C by how much one number exceeds the other. The second method involves division. We calculate a divided by B to see how many times one number is of the other. Let's visualize these two methods. Here we have a number line with the numbers 4 and 7 marked on it. Using the first method, subtraction, we can find that 7 minus 4 equals 3. This tells us that 7 exceeds 4 by 3 units. Using the second method, division, we calculate 7 divided by 4, which is 1.75. This means that 7 is 1.75 times larger than 4. Let's now understand when to use each method through some practical examples. Consider comparing the ages of two people, Alice, who is 40 years old, and Bob, who is 25 years old. Using the subtraction method, we can find that Alice is 40 minus 25, which equals 15 years older than Bob. Using the division method, we find that Alice's age divided by Bob's age is 40 divided by 25, which equals 1.6. This means Alice is 1.6 times as old as Bob. So, when should we use each method? The subtraction method is more useful when we're interested in the absolute difference between two values. This is particularly helpful in contexts like age differences, temperature changes, price differences, or height comparisons. The division method is more appropriate when we want to understand the relative scale or proportion between two values. This is useful in contexts like salary comparisons, population growth, price increases over time, or efficiency ratios. Let's look at a practical example. Emma and James work at the same company. Emma earns $70,000 per year, while James earns $50,000 per year. Let's compare their salaries using both methods and see which one gives us more meaningful information. Using subtraction, we find that Emma earns $70,000 minus $50,000, which equals $20,000 more than James per year. Using division, we calculate $70,000 divided by $50,000, which equals 1.4. This means Emma earns 1.4 times as much as James, or 40% more. In this context, both methods provide useful information. The subtraction tells us the exact dollar difference, while the division gives us a proportional comparison that helps us understand the relative scale of their salaries. Let's look at another example. The temperature in a city was 5 degrees Celsius in the morning and rose to 20 degrees Celsius by afternoon. Which comparison method makes more sense in this case? Using subtraction, we find that the temperature increased by 20 minus 5, which equals 15 degrees Celsius. Using division, we get 20 divided by 5, which equals 4. This means the afternoon temperature was 4 times the morning temperature. In this temperature example, the subtraction method provides a more practical and intuitive understanding. We typically talk about temperature changes in terms of how many degrees it increased or decreased, rather than as a multiple of the previous temperature. Here's one final example where the division method is clearly more appropriate. An investment grew from $1,000 to $3,500 over 5 years. How should we describe this growth? Using subtraction, we find that the investment increased by $3,500 minus $1,000, which equals $2,500. Using division, we calculate 3,500 divided by 1,000, which equals 3.5. This means the investment grew to 3.5 times its original value, or increased by 250%. For investment growth, the division method typically provides more meaningful information. Financial growth is commonly expressed in terms of percentage increase or as a multiple of the original amount, rather than just the absolute dollar increase. To summarize what we've learned, we have two primary methods to compare real numbers: subtraction and division. The subtraction method, a minus b, tells us by how much one number exceeds the other. This is most useful for measuring absolute differences. The division method, a divided by b, tells us how many times one number is of the other. This is most useful for understanding relative scale or proportion. The choice between these methods depends on the context and what information would be most meaningful in that specific situation. Today, we're going to learn about comparing two numbers, determining which number is larger, smaller, or if they are equal. Let's start with our first rule. If the difference of two real numbers is positive, then the first number is larger than the second number. Mathematically, if a minus b is greater than 0, then it is greater than b. So we can write a minus b is greater than 0 if, and only if it is greater than b. Let's visualize this with an example. Imagine we have a big dog and a small dog. The big dog represents the number a, and the small dog represents the number b. When we say it is greater than b, we can think of it as the big dog being larger than the small dog. The difference between them, a minus b, is positive. Now, let's move on to our second rule. If the difference of two real numbers is negative, then the first number is smaller than the second number. Mathematically, if a minus b is less than 0, then a is less than b. So we can write a minus b is less than 0 if, and only if it is less than b. Let's visualize this with another example. This time, we have a big object and a small object, but their positions are reversed. The small object represents a, and the big object represents b. When we say a is less than b, we're saying the smaller value comes before the larger one. The difference between them, a minus b, is negative. Finally, let's cover our third rule. If the difference of two real numbers is 0, then the numbers are equal. Mathematically, if a minus b equals 0, then it equals b. So we can write a minus b equals 0 if, and only if it equals b. Let's visualize this with one more example. Here, we have two identical objects. One represents a, and the other represents b. When we say a equals b, we're saying the values are identical. The difference between them, a minus b, is 0. Now, let's summarize all three rules together. Welcome to our lesson on comparing variables in algebraic equations. Today, we'll solve three different problems to determine which variable is larger in each case. Let's begin with our first example. We are given the equation a minus b equals 1. The question asks us to determine which variable, or b, is larger. Let's solve this step by step. To find which variable is larger, we need to isolate the variables on opposite sides of the equation. Starting with a minus b equals 1, we can rearrange this to a equals b plus 1. This shows us that a is equal to b plus 1, which means a is 1 more than b. Therefore, a is larger than b. Now, let's move on to our second example. This time, we have the equation u minus v equals negative 2. Again, we need to determine which variable is larger, u or v. Let's solve this second problem step by step. We start with u minus v equals negative 2. Rearranging, we get u equals v minus 2. This means that u is 2 less than v, or v is 2 more than u. Therefore, v is larger than u. Finally, let's look at our third example. Here we have the equation 2 times open parenthesis p minus 1 close parenthesis equals 2q minus 3. We need to determine which variable is larger, p or q. Let's solve this more complex problem step by step. We start with 2 times open parenthesis p minus 1 close parenthesis equals 2q minus 3. First, let's expand the left side of the equation. 2 times p minus 1 gives us 2p minus 2. Now our equation is 2p minus 2 equals 2q minus 3. Let's add 2 to both sides of the equation. We get 2p equals 2q minus 3 plus 2, which simplifies to 2p equals 2q minus 1. Now, we divide both sides by 2. This gives us p equals q minus 1/2. This means that p is half a unit less than q. Therefore, q is larger than p. Let's summarize what we've learned today. When comparing variables in equations, we need to isolate the variables to see their relationship. In our first example, We found that A equals B plus 1, so A is greater than B. In our second example, we found that U equals V minus 2, so V is greater than U. In our third example, we found that P equals Q minus 1/2, so Q is greater than P. The key insight is to rearrange the equation so that one variable is expressed in terms of the other. Then we can directly compare their values. Welcome to this mathematical video, where we will explore the relationship between real numbers. For any two real numbers, A and B, exactly one of the following three relations must be true. A is less than B, A is equal to B, or is greater than B. Compare the real numbers 3 and 5. Since 3 is to the left of 5 on the number line, we can see that 3 is less than 5, or mathematically written as 3 less than 5. Let's consider another example. Compare the real numbers 7 and 7. Since these are the same number, they would be at the same position on the number line. Therefore, 7 equals 7. Now, for our third example, compare the real numbers 10 and 2. Since 10 is to the right of 2 on the number line, we can see that 10 is greater than 2, or mathematically written as 10 greater than 2. This property we've been exploring is known as the trichotomy property of real numbers. The trichotomy property states that for any two real numbers, A and B, exactly one of the following relations must be true. A is less than B, A is equal to B, or is greater than B. This is a fundamental property of real numbers and forms the basis for comparison and ordering in mathematics. Welcome to this mathematical inequality lesson. Today, we're going to understand how to write inequalities for specific situations. Let's look at our first example. James plays in an under-15 football team. We need to determine how to represent James's age mathematically. We don't know James's exact age, but we do know that he plays in an under-15 team. This means his age must be less than 15. If we denote James's age as age, then we can write this inequality as age is less than 15. Let's look at our second example. To participate in a young writer's competition, you must be over 12 years old. Let's express this as an inequality. In this case, we need to represent that your age must be greater than 12 years. So if we use age to represent the person's age, we can write this as age is greater than 12. For our third example, to be a heavyweight boxer, you must weigh at least 110 kilograms. In this scenario, the weight requirement means the person's weight must be equal to or greater than 110 kilograms. If we use weight to represent the boxer's weight, we can write this as weight is greater than or equal to 110 kilograms. Our final example is about exercise time. James decides that for fitness, he must exercise more than 2 hours per day. Here, James wants to exercise for more than 2 hours daily. If we use time to represent his exercise duration, we can write this as time is greater than 2 hours. Let's summarize what we've learned about writing inequalities from word problems. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.